Greetings everyone. Today we're going to explore monomials a little bit more and what we can do with them. So we're looking at this prefix of monomial, meaning one term. We're going to factor that one term and distribute that one term. All right, so let's start off by taking some notes on a few definitions. The first being distribution. Think of what distribution means to you in the real world. If I'm distributing out papers, I'm giving everybody in the class a piece of paper. So distribution in mathematics involves multiplying each term in a grouped series by a term on the outside of the grouping. So the term on the outside is like the teacher. And I'm going to distribute the paper or quiz to everybody in the class. Now, this is something you've probably seen in the past, but we're really going to amp it up in the expectations. So let's take a look at a few examples. Take a moment to pause the video, jot these down, and then let's work them out. So the first example, I have a single monomial on the outside of a grouping. So this single monomial needs to be distributed completely in. So this is a process that you've done before. It's just now when you look at that monomial, there's also a variable included. So what I'm looking at here is, I'm going to show this sort of the long way to start. This means 2x times x, all right? And then if I distribute it again, that means a 2x times 8. Now, I would just expect you to show the arrows. I just wanted to write it out to make it a little easier. So I've got a 2, x times x, careful, is x squared. I have a 2x times an 8. Well, let's see, the like terms that I can multiply are 2 times 8, so that's 16x. There's a plus sign in the middle of my binomial, so it's a positive, okay? So there would be my new polynomial. Now, in example 2, the only difference here is that my monomial's on the right side. It doesn't matter where I'm standing as a teacher in front of the class, right? What matters is that if I'm distributing that piece of paper, that everybody in the class gets that piece of paper. So again, I'm going to show the work. You don't have to, but I have 5n times n. That'd be the first set of terms. And then I also have the 5n times 7. So 5n times n, well, n times n is n squared. And 5 times 7 with an n gets me to 35n. It is a positive sign. It's an addition, so it's going to remain positive. Let's take a look at this next one. This time I actually have a monomial, and I'm multiplying it 3 times because there's 3 terms, okay? So let's look at the first move. The first move is a negative 3c times 8. The second move is a negative 3c times positive 2c. And now my third move is a negative 3c times a negative c cubed. All right, so again, I don't expect you to write that out. I think a lot of you can handle that multiplication in your head, no problem. So negative 3 times 8, we get a negative 24c. A negative 3 times 2 is a negative 6. A c times a c is a c squared. A negative 3 times a negative 1, there's technically a 1 there, is a positive 3. And the c times c cubed. Now here's going back to our exponent rules. When I multiply like bases, I add their exponents. So this is c to the 4th. Okay. Now normally we would say we're done, but we have one extra step. I want you to make sure to write your answers in standard form. So we're going back to the previous lesson, meaning I want the highest exponent first, which is a positive 3c to the 4th. Next would be a negative 6c squared. And last would be a negative 24c. So now they are in descending exponent order. So not too bad. Some of you might be able to jump from the questions to the answers right away on a lot of these, and I'm okay with that. If you need to show a little extra work, that's fine. Really what I'm looking for is the arrows showing me that you knew that every piece gets multiplied. All right, let's talk about a new definition of factoring. So to factor means to find out what was originally multiplied. So we're thinking backwards almost. It's almost like we're undoing the multiplication process. So to factor is to find out what was originally multiplied. Now, we're going to do a lot of factoring in this unit, but today we're going to start off with just basic, greatest common factoring. And you guys have done like factor trees in elementary and middle school. So think about those things as we go through this. So the greatest common factor, or you might have heard it abbreviated as GCF in the past, is what is the largest number and or variable or variables that can be divided out of each term in the expression. So greatest meaning what's the largest, common meaning every term has it, and factoring meaning we're undoing the multiplication. So don't jot this down, but let's just take a look at some factoring. So if I'm talking about the numbers 4 and 5, what's the largest number I can divide out of both of those evenly, cleanly, however you want to think of that? Well, actually, the only thing I can take out, of that first one is a 1. Let's talk about 4 and 6. What can I divide out of 4 and 6 cleanly? Well, a 2. A 2 would be the highest I can take out. How about an 8 and a 12? Think about that. A 4. I can take a 4 out of both of those, that greatest. So thinking about 8 and 12, 1 goes in, 2 goes in, 4 goes in. There's a lot of factors, but I'm looking for the greatest, okay? That G, greatest matters. How about out of 8 and 16? Well, all the factors would be 1, 2, 4, 8. 8 is the greatest factor I can take out. So same idea, what's the only thing I changed here? Again, you don't need to write this down. I have a variable, meaning if I can divide out a variable out of both of those, then I need to. So my GCF and these ones would be the same numbers, but now I can factor out an X with it. So that's really the step up here, is including more variables. All right, so let's take a look at an example of what we're talking about here. And you do not have to write this one down. I just want you to follow along and get an idea of what I'm looking for. All right, so the first thing, we're looking for what is the greatest common factor. I'm trying to undo the multiplication, okay? So first of all, let's count how many terms. I have 1, 2, 3 terms. And I want to see what I can divide out of all of those. So my suggestion is to mentally sort of think of, I've got the numbers 3, 9, and 12, and two of them are negatives. So do they all have a negative in common? No. So I don't want to take a negative out. But what number can I divide out of all of those evenly? So the GCF of that would be a 3. Let's take a look at the variables now. I have 4 x's, 2 x's, and a single x. What's the most x's I can divide out? An x to the first. I can't divide more than what I have in my terms. So one of the ways that I like to think of this actually is then, I like to show old school division. This is just my preference. You do not have to show it this way, but for monomials it's kind of easy. Meaning I can divide a 3 out of each of these, right? And I can divide at least one x out of each of them. Notice that my repeated division pattern becomes my GCF. This is the monomial that I'm factoring out. Okay, I'm undoing the multiplication. So now I want to actually divide. 3 divided by 3 is 1. X to the 4th divided by x to the 1st. When you divide like exponents, or excuse me, like bases, you subtract their exponents. All right, let's take a look at our next term. Negative 9 divided by positive 3 would be negative 3. X squared divided by x, or exponents 2 minus 1, is 1. And our last term, negative 12 divided by 3, watch your signs, negative 4. X divided by x is 1. So I just leave it as a 4. I don't need to write 4 times 1. That is unnecessary. So what I have written is now my factored form of my polynomial. So let's add a few examples to your notes. You'll want to pause, jot these down, and if you really want to try them on your own first, and then press play, you can see how you did. So let's look at this example 4. I'm just basing it on the previous examples from this lesson. What can I divide out of 6, 12, and 18? A 6. Now the 18 doesn't have an x, so that's all I can divide out. That is my GCF. 6 divided by 6 is 1, and I have an x squared. Negative 12 divided by 6 is negative 2. And 18 divided by 6 is 3. All right, let's take a look at this next one. 2 terms, 14 and 7. Well, I can divide out a 7. That would be the greatest. And I have an x to the 4th and x to the 1st. The most I can take out would be a 1. So my GCF on this one is 7x. 14 divided by 7 is 2. X to the 4th divided by x to the 1 is x to the 3rd. Negative 7 divided by 7 is negative 1. X divided by x is also 1. So I just need to write the 1 once. And the third example, or example 6 that I have here, look at this. I actually have 3 terms. So numbers first, 28, 16, and 8. I always start with the smallest number. Let's see, 8 fits into 8, 16, ooh, but not 28. So I'm thinking of all these factors of 8. So 8, 4, 2, 1. I want the greatest, so 8 didn't work. 4 fits into 8, 4 fits into 16, and 4 fits into 28. So that is going to be the largest number I could take out. All right, I have 2 x's, 5 x's, and 1 x. So the most I can take away without going negative is 1. Then I have a y, and a y squared. So the most I can take out, since they all have at least a y. All right, let's try this out piece by piece. That means my GCF is 4xy. Big parentheses. I like to fill in the blanks. 28 divided by 4, 7. X squared divided by x, x. Y divided by y, 1. All right, positive. 16 divided by 4, 4. X to the 5th divided by x to the 1st. Subtract the exponents. Y divided by y, 1. Plus sign. 8 divided by 4, 2. And then I said plus sign because they're both positive, so I knew I was going to arrive at a positive answer. X divided by x is 1. Whoops. Sorry, my pen went a little crazy. And y squared divided by y, 2 minus 1, 1. Now when you look at these answers, here's how you can kind of sort of self-evaluate how you did. When you look at your polynomial, meaning what's in parentheses, if you can't take anything else out, you're probably in a good spot. Like if I look at the blue one, example 4, there's no other x's I could take out of all 3. There's no other common number. In the green, example 5, that's a single term of 1, so there's nothing else I could take out. And if I look at the red, example 6, there's a couple x's, but the last term doesn't have one. There's a y, but the other terms don't have them. 7, 4, and 2, don't have common factors. So just looking and making sure nothing else will divide out reassures you that you possibly did pick the greatest common factor. All right, an extra example, if you're looking for one, this one's up to you if you want to jot it down. Let's take a look. I only have 2 terms here. All right, let's start with the numbers. What fits into 8 and 32? 8 itself. Okay, think of the factors of 8 from biggest to smallest. 8, 4, 2, 1. 8 fits into both. Okay, sometimes you're dividing by the number itself. M, they both have M's. The largest is 3, the smallest is 1. So the most I can take out is 1. N, they both have N's. I have N to the 4th and I have N squared. So the most I can take out is 2 of them. Now let's actually divide. My GCF is 8mn squared. Everything's positive, so I'm just going to fill in that plus sign right away. 8 divided by 8 is 1. M cubed divided by m to the 1st is m squared. N to the 4th divided by n squared. 32 divided by 8, 4. M divided by m cancels, or becomes 1, technically, and n squared divided by n squared is also 1. So in this case, I actually only have a term of 4 left over on the end. See how that parenthesis is really broken down, what's left over? Okay, that's our goal. We're trying to make the polynomial smaller. All right, so let's take a look. To double check what you need to do, make sure that you check Google Classroom. What are the expectations? What's next after this video? Make sure if you have questions, you guys, let me know. Email me, message me, whatever you need to do. But just keep me in the loop on how you're doing. And if you need anything at all, even outside of this, okay, get a hold of me. But until next time, hope you have a good one.